the Micronas Wafer FAB in Freiburg. To keep the clean room dust-free, all employees have to change their clothes in an elaborate procedure, because a clean room is required to be extremely clean. No more than one particle of dust with a diameter of 3/10,000ths of a millimeter is permitted in 1 cubic foot of air. Any remaining particles are held back by the air shower, the last airlock before entering the clean room. The starting material used in chip production is thin slices of silicon with an extremely high level of purity, which are known by the technical term of wafers. Although the wafers are extremely clean at each stage of the production process, cleaning steps are run through at many different points of the process. This is because any remaining foreign substances could impair the quality of the products, especially during oxidation and diffusion processes. Thin layers of silicon dioxide are generated on the silicon wafers through thermal oxidation in high-temperature furnaces. Silicon dioxide is the basic insulating layer employed in semiconductor technology. The oxide layers are then structured in the further course of the process, and their electrical characteristics modified through the implantation of ions. The transistor properties of an electronic circuit are defined with the aid of these layers. The specific product being made, in other words a particular integrated circuit, is defined and structured via photomasks. Up to 20 individual photomasks are required to create functioning circuits from the bare silicon wafers. The photolithographic process is repeated for each individual photomask after the previous layer has undergone further physical and chemical processes, such as diffusion, ion implantation, coating and etching. In this way, the desired structures are generated on the wafer on a layer-by-layer basis. Before the information on a photomask can be transferred to the silicon, the wafer is first coated with a thin, light-sensitive layer. This light-sensitive layer is the reason why all the work in the photo section has to be performed under yellow light. After the wafer has been coated, it's exposed like a film, so that the information on the photomask is demagnified and transferred to the wafer using high-resolution optics. This requires an extremely high level of accuracy in the resolution of the structures, 0.5 microns, and their positioning on the wafer. The exposed wafer is then developed as the next step. To ensure that any deviations in the process are detected as early on as possible, the processed wafers are subjected to a comprehensive quality inspection after almost all the individual production steps, and after each photolithography process in particular. Extremely stringent requirements are placed on a clean room for the manufacture of integrated circuits. Extremely clean air, no structural vibrations, a stable temperature, a uniform air supply, plus a great deal more. All this calls for elaborate installations in the building. The circulating air filter systems ensure that there are no particles in the clean room and that a laminar airflow prevails without any turbulence. The volumetric airflow is about 700,000 cubic meters per hour, which means that the air circulates 400 times an hour. At the same time, the air in the room is kept at a constant 22 degrees Celsius throughout the year, with an air humidity of 45%. Coating constitutes a further key process in semiconductor production. Ultra-thin layers, such as insulation layers, barrier layers, and conductive layers, are generated through physical and chemical deposition processes. These deposition processes are generally technically complex multi-layer processes with integrated etch-back steps in some cases. During the etching process, the photoresist structures that have been built up are transferred to the layer beneath by means of ionic chemical etching processes. In this way, contact holes are made through insulator layers and conductor structures. After etching, the photoresist is removed, a further quality inspection run through, and the wafer cleaned many times over. The next process can then be oxidation, coating, or an ion implant again. Statistical process control is used to keep the processes within the specification limits on the basis of so-called control charts. Immediate action can then be taken in the event of any inadmissible deviations in the process parameters. Implanters are essentially particle accelerators. They have the task of selectively incorporating foreign ions into layers that have already been applied, such as oxides. This then creates areas with different levels of doping and defines the transistor properties of the electronic circuit. Once implantation and etching have been completed, any photoresist that's no longer required is removed by wet chemical processes. Once the structures of all the photomasks have been transferred to the wafer and the required electrical properties achieved in all the layers of the integrated circuit through the processes described, the production steps in Wafer FAB are now complete. Much of the work carried out by employees in Wafer FAB is quality assurance. Repeated inspections and systematic analyses ensure that the products that leave the company always meet up to our customers' stringent quality requirements.